Hello, hello. It is 3 o'clock Central Time, and I am going to begin to get started here. I'm glad so many of you have joined. Really, this response has been quite overwhelming, and that's great. This is a pretty big topic these days, so much so that it's gotten our company really in the throes of providing this kind of consulting and help with companies. We've been concentrating on this area for about 3 years and have developed some software products and practices around it. But today we're not going to talk about any of that. We're going to talk about just some of the things we've discovered, some of the things we've found, and again, really glad that you guys are logging in and watching. Some housekeeping items, and if you can't hear me or having difficulties, I really apologize. Of course, if you can't hear me or are having difficulties, you didn't hear any of that. So it seems kind of strange that I would be telling people that who can't actually hear me. But anyway, all of that aside, thanks. I'm going to try to keep this to about 30 minutes, and we'll go on and go ahead and start now. You should be hearing me through the interface. If you can't, you've probably figured it out or not by now. There's 2 options, one through the phone or one through your computer. You can use either. We will. I'm not going to answer any questions directly during this time because of time restraints. We should be about 30 minutes for this presentation. The link to the webinar and the presentation will be sent out by email to all participants. We're actually recording this right now, the screen you're seeing, so you'll be able to see that and share that, as well as the presentation itself. And if you have any questions, let's reply to the emails that I've sent you instead of trying to do that here. And anything that I think would be good for the entire community to share, we will do that in a follow-up, sort of an FAQ. So what this webinar is not. It is not a sales presentation for Mangan or MSS or ProSysDR, and it is not a discussion of detailed requirements of instrumentation engineering standards that OSHA has adopted and that the ISA community has adopted. We're not going to be talking about those in detail. We're talking strictly about data management techniques, and it's a pretty short topic, and it's also not a very long webinar, so that can be good. What this webinar is, it's a simplified overview of the documentation requirements per one standard, and this can apply to all, be it relief systems or any other standards your company may use internally or may have adopted. It's just a data-centric, kind of a geek's perspective to preparing yourself to manage and put your hands on that data as you need it and when you need it for whatever reason. We're going to talk about an outline of challenges around managing this documentation. We'll do that largely in just some of the comments I make and some of the stories I may tell. And this is a data-centric approach to a solution that can be executed by your team right now with no new software or systems. So let's get started then. A few more have joined here, and we're going to go ahead and get started. About us, Mangan is a $50 million engineering automation services company, 5 offices with 300 employees. Our software as a company is a subsidiary of Mangan Inc., and we provide software and consulting services to meet process safety data management challenges. I am an employee of MSS and currently an engagement manager in our software implementations. So where are we coming from then? Mangan's involvement in safety systems assessment projects have really highlighted the need for a formal approach to this challenge. And over the past 3 years, Mangan has fine-tuned this approach and built a consulting practice and a software business around it, and we're happy to share what we've learned. So, from the very beginning, the life cycle of a instrumented safety system, really any safety system, if you really boil it down, comes down to some very simple and straightforward pieces. And this is for specifically those systems which are related to safety and keeping things safe. Step 1 is the hazard analysis and the assignment of independent protection layers. Number 2 is the engineering design of the solution and the documentation of that. And thirdly, operate, maintain, failure tracking, and eventually decommissioning. These are the very, very simple steps. Everyone understands these things. Everyone knows their place and their role. From a documentation standpoint, the S84 standard does outline some documentation requirements for managing the life cycle of these safety systems. And this documentation becomes important as you try to demonstrate to the regulatory community or to yourselves your operational readiness or effectiveness to protect the very hazards that you're designing your system to protect you against. So, for hazards analysis and assignment of IPLs, you're looking at your PHA, your LOPA, and the results of which being your IPL list. That is a critical output of that process. What are my actual assets and groups of assets that are going to be protecting me against any hazard? Secondly, under the engineering side, there is, in the instrumentation world anyway, a safety requirement specification that must be written and maintained and managed and kept evergreen as new systems are brought online or as systems are changed or decommissioned. And then the last step, in operate and maintain, we must show training programs, proof of training, operations, instructions, and proof of those executions, as well as some sort of tracking of our failures and what we did to address those failures and investigate them. So all of those things are very important to keep. Now, what are we finding in reality? And again, this is where I kind of have to pause and say a couple of things. One, it's interesting to us that this seems like such a simple set of data that needs to be collected, but what we actually find is, in fact, that they are unlinked systems out there, a lack of continuity and visibility to each other's data. I keep getting pop-ups here on the webinar that we've actually reached max capacity, so that's good and bad news. So there is no common thread that hooks all of these pieces together, no centralized verification, and data audits across these islands need to be easier. So instead of finding aggregated data across all these data islands, we're finding that they exist in islands across the enterprise, right? In all kinds of different systems that we maintain. Now, there's not a problem with that inherently if you are a member of that data island. But when it comes to being able to reconcile that we have written engineering specs for all of the items on the IPL list, that we are properly maintaining and testing and running in our maintenance program tests against the proper set of tools, then we can't find those things out very easily. This is what, in fact, we typically find. Data in each silo is typically poorly organized, stored on paper or deep within systems with no key data to aid in linking and searching. In the PHA side of things, we'll find PDFs or Word documents of the PHA and LOPA studies. In those studies, we typically will not find any referenced asset tags. That may be appropriate when they are initially released because you may not have assets built to actually mitigate hazards. But what we'll talk about soon, it's important to go back and update those to reflect the actual asset IDs, and those things aren't being done. LOPAs of record are typically not searchable, not indexed in any way, and are just stored and put on a shelf. For safety requirement specifications, for some reason, we're still accepting Word and PDF documents from our engineering partners instead of consistent database approach. So we're finding that the content, even from the same engineering organizations over time, is inconsistent. We at Mangan even have that, are guilty of that. Our deliverables over time for safety requirement specs in the instrumentation area has been inconsistent. Thirdly, in your operate and maintain, we have found SAP configurations which do not take full advantage of the ability to track at a detail level certain failure rate information, no ties to the assets that are in the SRS, and we find simplistic spreadsheet-based tracking. Now, none of these are bad things, and I know a lot of you probably are thinking, why is this guy talking about such simple things? Well, it's interesting in that even though it seems like keeping these data points together and working with the teams to tie all these things together it should have been done, and we have systems that try to organize our data. There has been largely no projects to actually tie things together. So that's what we're going to get into now. We found that a very few simple changes can make all the difference to keeping data on track. And while these changes are simple, they are not easy. Many departments must be bought in and they must work together. And again, these ideas may seem elementary, but based on what we found, very few companies have these practices in place, usually just for lack of time. But in some cases, it's for lack of understanding the importance of being able to tie all these pieces together. So let's talk about these three areas in three chunks. So best practices for the PHA and LOPA side of the house. It's very important that we store our LOPA results in some sort of searchable index so that we can easily relate our assets back to IPLs and cause-consequence pairs. We go through all this trouble to do these LOPA and PHA assessments, and we are not storing that data in an evergreen retrievable format. Step two, regardless of what methodology you use, whatever software you're using, and we've come across your PHA Pros, your PHA Works, spreadsheets, things, all sorts of things we've come across as we've analyzed client data. But regardless of what methodology is being used, companies will rarely go back and update those LOPAs and PHAs to reflect the actual asset tags that are implemented as IPLs. What do I mean by asset tags? You see I have here in this diagram the notion of nodes, deviations, and cause-consequence pairs, or consequence-cause pairs, however you think of it. And then an IPL group that mitigates that hazard. Now that group could be made up of an alarm, RV group, or a safety function, instrumented safety function loop. That information, those loops or alarms or RV groups, will have asset tags in the field on some PNID somewhere. And the first step, and again, it may sound obvious, but we have yet to see it done natively at facilities. But the very first step is to go back to those LOPAs and PHAs and update those IPLs that were recognized with the actual asset tags in their own column, and also capture the asset type. Now, what does that do for us? Well, getting to an IPL list is now elementary. We can ask our LOPA database, please show me for every unit, for every IPL type, how many assets do I have playing a role of IPL mitigation or hazard mitigation for an alarm? How many alarms are being used in hazard mitigation, for example? Because you're adding a minimum amount of data to each IPL group, including asset type and asset tag, which, sorry, you can't see those words there. But if we add at least asset type and asset tag to our cause-consequence pairs, then we can ask very simple questions like that. How many alarms have a severity E? How many safety functions are being called upon to mitigate hazards in XYZ unit, right? We can see what assets are reused and how they're distributed among our risk types and risk groups. And as new LOPAs are released, it's easier to see changes when data is organized hierarchically. And we can track assessments of our LOPAs in the data itself by adding checklists or notes to the IPLs themselves, recommendations and so forth. And all these things get tied back, again, to an actual, countable, touchable asset tag in the field. This sounds simple, again, but we're not seeing companies typically do this. Now, talking about SRS, requirement spec for instrumented systems. Let's talk a little bit about that. What we recommend as a best practice is that companies create a database or spreadsheet for key SRS information, including input processes and output tags, and to do similarly for other IPL types, including voting logic and things like that. Now, we do see increasingly people putting SRS information in Microsoft Access databases or spreadsheets. What those typically come from will be an IPL list that they then grow and expand to be a sort of a mini safety requirement spec, or perhaps it's a testing database so they can keep track of what to test and when, and that's all good. But even those small spreadsheets, those helper tools, lose track of the original hazard or may lose track of the actual list of test procedures down the line. So we suggest that for each asset listed in the LOPA, create an entry in the database ensuring that naming conventions for each asset are strictly adhered to. So in this diagram, you can see that the data coming in from the LOPA will result in, and we'll go back, will result in a list of assets. Notice here in this LOPA diagram, I've got asset B being shared across a couple of IPL groups, and that's entirely appropriate. Now we take that information into the SRS, pull that same asset tag, and go ahead and split it out into its input and output tag components, logic solver components. At whatever asset level detail you want to track, let's go ahead and build a parent-child type relationship along with key SRS fields against that CIF loop or that SIS box, so that we can easily query this information in the future. Now, what does this give us? Critical instrument lists are now automatic, right? Shared devices are obvious. If you have shared output valves among a few loops or among a BPCS and a non-SIL rated interlock, you can see those very easily because that data is related to each other. Progress on SRS completion can be seen by just examining the database and asking, well, what fields are filled in and what all yet needs to be done. Thirdly, our contract engineers, our partners, can deliver SRS specs in the database format of our choosing, right? Instead of these unsearchable Word and PDF files. We should be asking our engineering partners for structured results instead of haphazard results as far as documentation is concerned, right? In other words, how am I going to be able to ask questions about set points or voting relationships if I have to search through pages and pages of information? Think about onboarding new people. Think about training folks in the field with the turnover that we get these days. Fourthly, we ensure the quality of deliverables by examining conformance to our database standard, your database standard, and not to a standard of someone else. And the third area is best practices in operations. So we take those inputs and output tags from the SRS, and now we build another database or an extension of the database that I've been talking about, or an extension of whatever tool you're using, that all things are kept together. We want to ensure that procedures are tracked not just by procedure name, but include in this database a list of those tags being tested per procedure. Also in systems such as SAP, we should ensure that work orders specifically mention procedure names for ease of lookup and cross-checking. We should also try to track events like failure on demand, for example, as children of the input and output tags. This only helps us in future calculations if you want to begin doing your own probability of failure on demand and so forth. Again, you may have heard a lot of this before, but the next slide really tells the story. What does this get us? When all of these data pieces are pulled together, when a test procedure is overdue, we know immediately the tag's involved. Since we know the tag's involved, we can query our SRS database to see which loops are involved. And with a list of loop numbers, now we can cross-check with our LOPA database to see what risks are now exposed due to that overdue test. So now we get into the beauty of the audit. So we just talked through the crux of what it is that I'm trying to share today and communicate. Again, this is an introduction to this idea. To a lot of you, you're probably rolling your eyes. Wow, this sounds so simple. And for a lot of you, it's verifying what you know that you need to be concentrating on. And in a way, this is me saying, yeah, you know, a lot of people are dealing with this, and we've been helping a lot of companies in this area. And it's a good issue to be thinking about because it's really next when it comes to trying to manage this data. So everybody is struggling with it, and everyone wants to do better by it. So what we're talking about here is when there is a common thread of data through this life cycle, assessing completeness of information and relation to the whole becomes straightforward and easily verified. And now many questions are now easy to answer. We talk about the audit being the rule of what the master data is. Where what we typically encounter with companies will be questions of, well, where is the master IPL list? Well, PSM will claim to own that. But then our Safety Instrumented Systems Authority will say, well, I own the master list because I know what we designed. Well, operations may say, well, I own the list because I know what I'm maintaining. Or your IT department may say the same thing about a list in SAP. The beauty of the audit is when you and your IT department or you and your groups together work on a common way of exporting and connecting all of these separate databases into one set of audit tools that are easy to run, easy to query, and they can be live audit tools or they can be tools that are run monthly or quarterly. It really doesn't matter. The key is let's pull that IPL list and that asset list from our LOPAs and have that database in an extract file. And let's pull our SRS information from our SRS database and have those assets now linked to input and output tags and other critical devices. And then let's go ahead and do some exports of our SAPs, our Meridians, and other softwares to list procedures by tag name or including those tag name groups. And then with one master report, we can see where gaps are. Well, I've got some IPLs in my LOPA that don't have SRS entries, or I have CIFs in my SRS list that aren't on any LOPAs. This may mean simply that some LOPAs were missed or have not been included in the data set, but it also may mean that that data is lost or IPLs were decommissioned and no one down the road knew about that. And we're still testing these certain systems at a fixed interval because we assume they're safety related, right? Well, what other questions can we answer? What procedures cover my safety related valves? Well, you might say, well, today I've got a master list with my operations folks. They have a critical valve list. Okay, well, do you know that firm path that goes back to the original hazard? Do you know those hazard numbers? What LOPA are they on? When was that performed and who signed off on it? What alarms must be in place for my CIFs to be valid per IL levels? That's a question we can answer now very quickly. What inspections are overdue concerning Rosemont 3051 transmitters that are part of LOPA IPLs? All these questions and more are at hand when data is consistent in a searchable database and properly maintained. Again, the audit being the rule. When we devise reports out of these islands of data that can talk to each other and show gaps and show continuity, then we know that all the systems across the board agree. Are the set points in the SRS equivalent to the set points in my calibration system? Is the test interval in my SRS match up with the actual test that I performed in SAP? How often are you asking those questions now? And what formal process are you using to do that? We suggest that you today spend time up front to create the extracts and the master audits so that these questions are not only easy to answer when you need them, but very easy to demonstrate your readiness for operation when anyone asks, whoever that is. So what are the challenges of what it is we're talking about today? Doesn't this just add a level of data that needs to be managed? Well, no. Systems can be designed to read from export files, assemble data in one place, and audit continuity. Of course, you have what you need, right? But yes, if you aren't managing it to this level of detail already, you've got more work to do anyway. So if you don't already have a plan or a system in place to pull all this data together in an easy to audit way, then you already have a long road ahead of you. There is a lot of concern over data ownership. How do I overcome this? Well, it's important that the stakeholders understand the power of the audit, right? If the audit is correct, then everyone is aware of the shortcomings in the system and can work together to resolve them. And from a management perspective, audits and clean data are very addictive. So we have to work with everyone, get everyone together to agree that if we can work together to come to terms with an audit process, then we can work together to examine the gaps we have, and instead of pointing fingers at whose data is right and whose is wrong, the goal being let's just agree on what data is correct and then repeat those audits and keep things clean. So this sounds like a lot of work. Well, it is. But it's less work than the kind of waste that we see today. And we do see a lot of wasted time, a lot of unanswered questions, a lot of time spent pulling answers together or things getting lost in the mix. So the upfront effort is high. Maintenance, however, is straightforward. Audits, when they're designed correctly and run often, do manage themselves, and they highlight problem areas sooner. There are a lot of different players in this market from a software and consulting perspective. On the consulting side, you've got companies who will do purely the engineering side, or companies that will help structure the safety lifecycle management process, and then companies who help with filling the gaps in documentation. Got at least 3 large players right now who concern themselves with aggregating documentation and making sure that it's right and giving you a very good place to store that and centralize that. And those are all new software platforms, perhaps new consultative engagements that you could participate in if you wished. But at the end of the day, we're trying to highlight to you the fact that everybody struggles with this. There are some opportunities by talking smartly about how we store data and how we link data together to use tools you have and people you have and resources you already have to at least begin to go down this road and identify what hurdles you have to cross in order to make the best sense of the data that you have. That is actually the end of the presentation, and we are a couple of minutes early. So I'm not going to take any questions over the phone right now, just in the interest of time, and there are a lot of people participating, but I do appreciate your attention. If you have any questions, you can respond to the email that I sent. Thank you very much for your time. Again, this is an introduction to the concepts, an introduction to what our passions are. I will be sending an email of this presentation and a recording of the webinar that you can share with others. I apologize for some of the technical beeps and flutters that have been going on, but we do appreciate your presentation, and thank you very much for joining us today.